Hello to all my fellow travelers on Deep Dive. I'm the captain, and welcome to another exploratory journey into the depths of the unknown. Tonight, I want to take you on a voyage across the darkest, coldest ocean imaginable. An ocean where every memory, every thought, every piece of who we are is like a fragile message released in a bottle. But this ocean is merciless. Its waves are made not of water, but of time, and their purpose is to sink and erase every single one of these messages. Now, let me ask you a strange question. What is the most expensive, most costly act in the entire universe? Building a star? Forming a galaxy? No. The most expensive act in the cosmos is forgetting. Erasing just a single bit of information. By the end of this video, you won't just understand the shocking reason why, but you'll also see how this simple rule defines the ultimate fate of you and of everything. So, brace yourselves, because our dive tonight goes to the very deepest point of existence. Let's start with a very simple example. Imagine your computer. Every file, every photo, every word you type is made of millions of zeros and ones. Each of those is a bit of information. Now, what happens when you press the delete key? On the surface, nothing. The information just disappears. But physics tells us this disappearance is not free. Before being erased, that bit could have been a 0 or a 1. Two possible states. But after erasing it, there's only one state, an empty space. This reduction in possibilities, this move from order to disorder, has a real physical cost. Every time you delete one bit of information, a tiny, immeasurable puff of heat is released into the universe. This is called Landauer's principle. Forgetting has a cost. Information is not an abstract mental concept, it's a physical phenomenon. Every thought in your brain, every memory you recall, is a physical arrangement of neurons and synapses. And just like that bit in the computer, this information is subject to the laws of physics. And this is where we confront the biggest, darkest law of nature, the second law of thermodynamics. Or, in simpler terms, the law of entropy. Entropy is the measure of disorder in the universe. And this law states that in a closed system like our universe, entropy or disorder is always increasing. This is the arrow of time that pushes everything from the past into the future. A whole egg has low entropy. When you crack it and scramble it, its entropy increases. You never see a scrambled egg spontaneously unscramble itself back into a whole one. The universe is exactly the same. It is heading toward a final state of absolute disorder. Entropy is the main villain of our story, the force that wants to erase every message in every bottle. So what fate does this merciless law decree for our cosmic ocean? Based on what we see today, the accelerating expansion of the universe, cosmologists believe the most likely scenario is the heat death, or the big freeze. This is not a sudden, loud ending. It's a long, gradual, and infinitely sad fading away. Our journey into this future begins 100 trillion years from now. At this point in time, the very last star in the universe, a dim red dwarf, will burn out its final fuel reserves and fade like a dying ember. With the death of this star, the stelliferous era ends, and the cosmos is plunged into eternal darkness. After that, we enter the degenerate era. The only inhabitants of this empty universe are graveyards of dead stars, white dwarfs, neutron stars, and the hungry monsters called black holes. But even these are not eternal. Over trillions upon trillions of years, protons themselves, the very building blocks of matter, will begin to decay. Everything that was once a chair, a planet, or a human body will slowly dissolve into a thin soup of elementary particles. Finally, in the black hole era, the only structures left will be these dark giants, but even they are slowly dying in a long, drawn-out battle. Through a process known as Hawking radiation, black holes slowly lose their mass in the form of energy. This process is unbelievably slow. A supermassive black hole might take a Google years to evaporate, that's a 1 followed by 100 zeros, and after the last black hole evaporates, that's it. The universe reaches its final state, a vast, cold, dark, and nearly empty expanse. A uniform soup of photons and neutrinos, drifting far apart from each other. This is the heat death, a state of maximum entropy, a place where there is no usable energy left, no structures can form, and nothing interesting can ever happen again. This is the ultimate victory of entropy, the complete erasure of all information. You might ask if there are other scenarios. Yes, there is a faster, more violent end called the Big Rip, where the mysterious force of dark energy becomes so powerful that it first tears apart galaxies, then stars and planets, and in the final fraction of a second, even atoms and their subatomic particles. as if the very fabric of space itself were being torn asunder. But wait, before we fall completely into despair, let's bring this cosmic scale back down to us for a moment. Let's look at the most complex, most ordered, and lowest entropy structure we know of in the entire universe, the human brain. We, each of us, are a tiny, miraculous island of order in this vast ocean of chaos. All our memories, our identity, our love, and our fears are information stored in this biological structure. Is there any way to save this island from the storm of entropy? This question has led humanity to one of its most ambitious ideas ever, mind uploading or digital immortality. The idea is this: we transfer our consciousness from this fragile biological shell to a durable computational substrate. A digital afterlife. Two main methods have been proposed. The first is the scan and copy method. In this process, your brain is frozen and sliced, layer by layer, down to a thickness of a few nanometers. Each layer is scanned by a microscopic device to create a perfect map of all the trillions of neural connections in your brain, your connectome. Then, this map is simulated on a supercomputer. But a terrifying philosophical problem arises here, known as the copy problem. The philosopher Susan Schneider argues that this process isn't a transfer of consciousness, it's the creation of a perfect copy. From the perspective of the original biological you, there is no journey to a digital realm. Your consciousness simply ends with the destruction of your brain. What boots up on the other side is a perfect copy, one that has all your memories and swears that it is you, but it isn't you. It's a digital twin, born at the moment of your death. This leads us to an even deeper question. Can a computer simulation, no matter how perfect, ever be truly conscious? Or would it be just a philosophical zombie? An infinitely complex machine that behaves exactly as if it has feelings and memories, but inside there's nothing? No subjective inner experience? Since consciousness is a completely private phenomenon, we may never know the answer. So it seems that entropy, both on the cosmic and the personal scale, always wins, whether through the heat death of the universe or the paradoxes of mind uploading. It seems our story is a tragedy written before it even began, isn't it? This is where a hero, a rebel, enters our story. A man named Freeman Dyson, a legendary physicist famous for his bold thinking and his opposition to established dogma. Dyson could not accept this idea of the universe's ultimate pointlessness. He argued that a universe that contains intelligence and consciousness cannot be pointless. And this belief led him to one of the most astonishing ideas in the history of science. This is the turning point of our story, the moment that will make you look at everything you've heard so far in a completely different light. Dyson said, yes, heat death is a thermodynamic reality, but intelligence, entropy's greatest enemy, has an escape route, a clever hack of the laws of physics. In a revolutionary 1979 paper, he argued that an advanced, intelligent civilization could survive forever in this same cold, expanding universe. How? Dyson's logic was based on the thermodynamics of computation. As the ambient temperature of the universe drops toward absolute zero, the energy cost of performing a single computation also drops toward zero. Dyson proposed that an advanced civilization could survive by adopting a clever strategy. They would continuously slow down their metabolism and their thought processes. They would enter longer and longer periods of hibernation, waking up only for brief moments to think and compute. In this way, they could stretch a finite amount of energy over an infinite amount of time. As Dyson wrote, the pulse of life will beat more slowly as the temperature falls, but it will never stop. This is a breathtaking vision. Intelligence, in an endless dance with the laws of physics, could sidestep entropy and experience an infinite number of thoughts with a finite amount of energy. This is a rebellion against the end of history. Of course, to reach such a stage, a civilization would need unimaginable amounts of energy. And this brings us to Dyson's most famous idea, the Dyson sphere. This is a megastructure built around a star to capture its entire energy output. It's not actually a solid shell, but a massive swarm of satellites and energy collectors orbiting the star like a beehive. Building such a structure is a prerequisite for any civilization hoping to survive on a cosmic timescale. So perhaps the end of the universe isn't a story of a quiet, silent death. Perhaps it's a story of a great challenge, an endless struggle between intelligence and entropy. And this perspective leads us to an even deeper philosophical idea from Dyson. To explain the problem of evil, why suffering and hardship exist in the world, he proposed an amazing principle, the principle of maximum diversity. Dyson suggested that perhaps the universe wasn't designed for our comfort, but for maximum interestingness. A universe without challenge is a universe without growth, discovery, or meaning. A boring place where consciousness would stagnate. For the universe to be as interesting as possible, there must be obstacles and difficulties. Things like ice ages, plagues, wars, and even death. From this viewpoint, tragedy and hardship aren't flaws in the cosmic design, they are its essential features. They are the catalysts that force us to evolve, adapt, and overcome. Perhaps a universe without tragedy is not a universe worth living in at all. And now, let's return to where we began, to that fragile message in a bottle, to the physical cost of forgetting. We live in a universe whose primary law is the increase of disorder and the erasure of information. Yet at the same time, we as conscious beings are information-generating machines. With every thought, every piece of art, every act of love we perform, we are creating small, precious islands of order in this vast ocean of chaos. Perhaps immortality isn't about uploading our minds or living forever in a dying universe. Perhaps the true meaning of our existence lies in the struggle itself, in the fact that we, finite and mortal beings made from the dust of stars, have the audacity to stand against the infinite disorder of the cosmos and shout, "We were here, we thought, we felt." Every time you learn something new, tell a story, or share a memory with someone, you are performing a small heroic act against entropy. You are putting a new message in a bottle and casting it into the ocean of time. Maybe that bottle won't float forever, but the act of launching it is what gives our existence meaning. Thank you so much for joining me on this deep and slightly dark journey. I hope this dive has forever changed the way you look at every thought and memory you hold in your mind. Friends, we truly love having you as part of this curious crew, and we're so grateful for your presence. If you enjoyed this video, please give us the energy to create more journeys by liking and subscribing to the channel. And in the comments section, answer this question for me. If you could preserve just one memory or one piece of information for eternity, what would it be? Until the next dive, farewell.